Ignition sequence starts. 6, 5, 4, 3, 2, 1, 0.
I truly believe that responsive small launch will change the world.
Good afternoon, everyone, and welcome to the live stream for Virgin Orbit's Above the Clouds mission. We are live in our studio here in beautiful Long Beach, California, right down the road from our manufacturing headquarters. My name is Erica Wellnitz, and I'm the Senior Financial Analyst here at Virgin Orbit. And today, I'm joined by my two wonderful co-hosts, Paul and Spencer.
And good afternoon. We are so excited to be here with you today. My name is Paul Anderson. I am Lead Systems Engineer for Vox Space. Vox is Virgin Orbit's subsidiary focused on bringing Launcher One's responsive, flexible, dedicated launch services to the U.S. national security space enterprise. We're so excited to go above the clouds with you today over the course of this live stream, and we have a lot of exciting content over the next few hours. Over to our third co-host, Spencer.
And my name is Spencer Stebbins. I'm an aerodynamicist here at Virgin Orbit. A lot of the work I do was actually modify the same system in order to actually carry our rocket as well. Beyond that modification, we also did some other simple modifications like removing unnecessary weight, such as the passenger seats that sit on the 747, as well as the bar that actually is on the second floor of the 747. With these two elements, the rocket and Cosmic Girl, we were able to design an air launch system that was unparalleled in mobility and provided a way to create missions with greater flexibility. With that being said, let's take a quick look at our launch timeline so you can know what to expect throughout the rest of today's mission.
Expected warnings. Clearing flight software warning. Clearing S2 lock stiff warning. SMA, this is CE on control room. We are polling for good to take off.
Stand by for SMA.
Copy.
Let's take a look at some views from our launch site today up in Mojave Air and Spaceport in Mojave, California. Mojave Air and Spaceport originally opened as the Mojave Airport in 1935 and was granted its spaceport license through the Federal Aviation Administration in 2004, becoming the first private airport in the U.S. with a commercial spaceflight license.
So what you're actually seeing through some of these shots, especially this one, is a large wind turbine farm in the background. Fun fact about Mojave, it's actually home to the third largest onshore wind energy project in the world.
And if you're based in the LA area and plan on going skiing or snowboarding anytime soon up at Mammoth Mountain, you will drive right past the Mojave Air and Spaceport on the 14 freeway. And if you're lucky, you may even get a chance to see Cosmic Girl.
Yeah, and let me add this. Mojave has a rich history in aerospace flight testing and space industry development, but since it's located in the Mojave Desert, the only thing you'll find more dangerous than the rocket engine testing are the creatures that live there. The black widow spider, the tarantula hawk wasp, and the Mojave green rattlesnake, very poisonous, all call Mojave home, so watch your step.
I've actually seen a black widow in person, and those things are so tiny. It's impressive that they can pack such a horrible bite to them.
Absolutely.
Well, one more fun fact for you guys. This was actually where the VSS Unity of our sister company, Virgin Galactic, reached suborbital spaceflight for the very first time back in 2018.
Virgin Orbit and Virgin Galactic are separate but sister companies with a shared founder, Sir Richard Branson. Virgin Galactic is opening space for everyone by enabling affordable suborbital human spaceflight so that anyone can become an astronaut. I know I'd love to fly to space one day. But Virgin Orbit is opening space for everyone by enabling affordable, anytime, anywhere orbital access for small satellites that bring positive change to all of us back here on Earth.
So to help everyone at home differentiate between Virgin Orbit and Virgin Galactic, let's take a quick look at our launch simulation that we've put together for you.
I'm in charge of getting everything ready for launch day. So everything from making sure the plane is ready, the ground support equipment and the rocket are all ready to go, as well as the people on console and all of our procedures and operations are ready to support a successful launch.
The launch engineers on launch day, we're at L-0 day, it's our big game day. We first go out before rocket loading and we do our pre-flight checkouts just to make sure everything is good to go before we load cryogenics onto the vehicle.
For last launch, I came in after fuel load, and I sit on console to monitor the system during engine bleed and TVC bleed.
I'm really focused on the risk of our program, so any kind of technical or program risk that we have, and then if something comes up at the last minute, really working with those teams to disposition that and address it as quickly as possible.
It's amazing to be part of the launch operation team because it's kind of a testimony of like how hard the entire company works together, from manufacturing to integration to all the engineering support.
As soon as you release the rocket, I think it's honestly is when it hits you, because during the time of terminal count and all the way leading up to it, you're pretty laser focused. Really, it's not until after the release of the rocket that you really take all those emotions in.
There was a lot of intimidation walking into an incredibly successful company that was really ambitious with their goals, and to see that we had so much representation on our first operational launch was really, really special to be a part of, because I think it's the next step forward as the industry kind of recognizes the value of diversity in their workplace, but also being now at 50% representation, it's really great to not be the only woman in the room.
I think as a company, there's definitely room to grow and room for improvement and get the company at more of that 50-50 sort of level, but it is amazing to see so many females doing so many amazing things.
Alrighty, everyone, it looks like Cosmic Girl is moving towards the runway. She should be wheels up in no time. I'm pretty pumped. What about you guys?
Oh, I'm so excited. Oh, you can see such a beautiful shot of her right there as she's moving down the tarmac. Such a beautiful day in Mojave right now, especially you can see the size of Cosmic Girl on the rocket underneath wing. It's such an impressive sight.
Yeah, now Launcher 1 is 70 feet long, and when you're up next to Launcher 1, fully integrated in the factory, she looks to be a fairly large rocket, but under the wing there of a Boeing 747-400, this massive two-story commercial jetliner, Launcher 1 looks small indeed. But what an exciting moment here as we get ready for this distinguishing feature of air launch, the takeoff of the carrier aircraft from the runway.
And actually, that's one of my favorite things about working at Virgin Orbit. I work above the manufacturing shop floor, and we have like a nice window overseeing the whole flooring. So you can see pieces of the rocket as it comes together, and so you can see the size of it, and it's absolutely breathtaking. But when you see the whole thing put together, it's even more so amazing. I can't wait to see this baby launch today.
Yeah, and what's so inspiring, I think, about this, we have a lot of scientists, engineers, and future explorers who are watching this live stream right now. And, just a word to them, what you're seeing on the screen right now it's not taught in schools. You're not going to find a textbook that shows you how to do this. This right here, integrated plane, rocket, and satellites, all as a single system, that was born through ingenuity, creativity, and the imagination of a world-class team, I think one of the best in the world.
Engine 2 rotation. Engine 3 rotation. Clearing the AFSS fault logic, discussion with flight software. It was a blip, there's nothing in the error logs, and it was not seen on the plane.
Copy.
LD terminal, plane and control room. Please meet me on plane.
Well, as you can see, Cosmic Girl and Launcher One are still on the ground. We're taking this time to go through some final checks of subsystem performance and verification of system health. So stay tuned, stand by. We'll provide an updated takeoff time as soon as we have it.
And as you can see now, Cosmic Girl is taxiing towards the runway. Her engines are all warmed up and ready to go, so we should be wheels up in no time.
Yeah, again, very, very exciting. You can see the 70-foot-long Launcher One rocket safely nestled under the left wing there of Cosmic Girl, the Boeing 747 carrier aircraft. We're just moments away from one of the early stages of air launch, which is the takeoff of the aircraft from the runway. to begin our transit time of about an hour over to our Pacific Ocean drop point, at which point we will release Launcher 1 to begin powered flight to orbit. And there you have a successful takeoff of Cosmic Girl and Launcher 1 from the runway at the Mojave Air and Spaceport in Mojave, California. Looks like Cosmic Girl is on her way to going above the clouds.
I know. That was an absolutely gorgeous view of Cosmic Girl as she was taking off with the Eastern Sierras in the background. Well, a fun fact about the design for the rocket, one of the things we had to consider from an aerodynamic standpoint was making sure that the rocket didn't have too large of tail fins so they wouldn't strike the tarmac as Cosmic Girl was taking off. So we had to do a little design right there to get it just right.
And as a reminder, Cosmic Girl will be flying out to the Pacific Ocean to the drop point, which is about 50 miles south of the Channel Islands. And now joining us is a very special guest, the founder of the Virgin Group, the man, the myth, the legend himself, Sir Richard Branson.
Hi, nice to talk to you.
Nice seeing you today, Richard. So you were in Mojave for our last launch, Tubular Bells Part 1. How are you feeling after just watching Cosmic Girl take off?
Obviously, just like all of you, excited, always slightly nervous at this stage. You can never be sure in these early flights whether every mission is going to be successful. But just at the edge of my seat, like you and the rest of them, and it's incredible what the whole team have accomplished. I can't remember whether this is our third flight or fourth flight, but anyway, it's always incredible to be watching, and a great privilege.
Now, Sir Richard, the beauty of flexible small launch is that we can service a diverse array of customers on the same flight. On this one, we have U.S. government, U.S. commercial, and international customer payloads. What do you find most exciting about that?
Oh, look, I think that for people who question space exploration, they don't realize just how much it offers to mankind back here on Earth. I mean, one of our satellites that is going up today will be monitoring agriculture and crops around the world and so on. And it is that wonderful diversity of different organizations and different companies that have got brilliant ideas to try to use space to better things back here on Earth. And I think we've got something like 20 other customers waiting in the wings after this to put their projects up, and I'm sure there'll be many more after that.
Absolutely.
So let's talk about the future of Virgin Orbit, actually. I know we have a number of launches coming up. Which one are you most excited about?
I think that I was just looking at the 747 and having a little bit of a trip down memory lane. This plane was I think the second plane into Virgin Atlantic's fleet, something like 38 years ago. I wasn't sure that Virgin Atlantic would survive more than a year or two, and I don't think anybody were in those days. We were taking on, British Airways with 300 planes, and we had a couple of planes. I certainly was not sure that, or never dreamt that one day it would be taking off from Mojave with a giant rocket on its side, and putting satellites up into different places in space. And the tremendous thing about using a 747 is we can put them into any orbit from anywhere in the world. So it's definitely a pinch me moment. I mean, this goes right back to when I one day saw one of our 747s taking off with 3 engines on one side and 2 engines on the other, and we just suddenly thought, well, if you can get 3 engines on one side of a 747, maybe we could put a rocket on it. The reason for 3 engines on one side and 2 engines on the other was, if there's a technical problem in Alaska, you have to send one of your other 747s to bring a spare engine. The only way you're going to get it there is to put it on the wing. As to the future, I mean, I'm obviously excited about every single rocket launch and all the different things that all the satellites inside those rockets can do. I mean, there are so many urgent things that need doing back here on Earth. Whether it's monitoring the rainforests, maybe places like Norway who are doing deals with places like Brazil to ask them to not to cut down the rainforests, and then rewarding countries for for not cutting down rainforests. The only way you can properly check on it is really via satellite. I mean, you can do a certain amount on the ground, but to completely verify it on a month-by-month basis, you need to do it from the air. So it's projects like that. I mean, in the Virgin Islands, right here, we have illegal, fishing boats coming through. Again, it needs satellites to be able to alert the authorities that trawlers are coming through with massive nets and long lines and pillaging the seas that belong to the British Virgin Islanders, and that's the kind of role that Virgin Orbit can play, and Virgin Orbit is unique in the world. I mean, the fact that we can actually, there's only, I think, a couple of handfuls of countries that have the capability of sending satellites to space from their own countries. And now all 180 countries can use Virgin Orbit. They just need to ring us up. We can send a 747 and operate out of their own country and launch satellites for the first time. The UK is one good example. I mean, later this year, we should be launching from Cornwall. The UK's never put up its own satellites. Now, I think this year there will be two flights from the UK, putting satellites up from the UK, and there are many other countries that have expressed similar interests.
And one last question for you, Richard. So as you may know, we have many international viewers watching from around the globe, but in particular, we have a small number here in California, namely our Virgin Orbit employees, that are primarily watching from home with their families due to the coronavirus pandemic. Is there anything in particular that you'd like to say to them?
Well, first of all, to say, thank you for all you've achieved. Obviously, we hope for a successful flight, and if it's not successful, we'll be back putting up another rocket. I'm sure, knowing the lot of you within a month or two, but I'm sure it's going to be a success. To wish everybody well. I mean, our family and friends all got COVID over Christmas, and fortunately we were vaccinated and boosted, and therefore none of us got it badly. I mean, my wife, who's a bit older than me, hardly knew she'd had it. So if you can get yourself vaccinated, get yourself boosted, get yourself protected, you can then I think ride this particular Omicron variant, and be around to watch many more flights, but basically just say thanks very much. I mean, you've achieved something extraordinary, and I know that you'll have lots more extraordinary things to achieve in the years to come.
Well, thank you very, very much for joining us, Richard, and we hope to see you back shortly.
Thank you very much. Cheers. Good luck in the next hour.
Thank you.
Cheers.
Joining us live in the studio here in Long Beach, California is a special guest, Colonel Carlos Quinones, Director of the U.S. Department of Defense's Space Test Program, or STP for short. Colonel, thank you so much for being with us today and for taking the time away from your mission team to join us on air.
Absolutely. It's great to be back, Paul. I appreciate it. Great day today. Another opportunity for us to put additional capability into space, to continue to push the envelope and actually take care of business so we can get the warfighter the tools that they need.
Excellent. So tell us more about DoD Space Test Program, who you are and what you accomplish.
Absolutely. So the Space Test Program has been around for a long time, over 54 years. And the job of our job is to demonstrate technologies, upcoming technologies, to accelerate development of war-winning capabilities for the joint warfighter. Our job is we do this by taking those technologies, do the mission design, the vehicle procurement, we do the integration, launch, and operations, and then take and analyze those capabilities, those technologies, and see which ones are ready to go to the next level. And the next level means for operations and to support all the activities and the missions that the Space Force needs to do. And this is critical because the Space Test Program is helping the Space Force, the Department of Defense, Space Systems Command to go after the threat and make sure that we stay relevant and the equipment is ready to do the mission and support our brothers in arms.
Excellent. Now, this mission is part of the Rapid Agile Launch Initiative, or the Raleigh project. Could you tell us a little bit more about the goals of that project specifically?
Yeah, absolutely. So the Raleigh, which is the Rapid Agile Launch Initiative, is one of those, it was a congressional initiative, and it was meant to help a venture class launch, small launch providers with using commercial practices to come and be able to support the mission of the Department of Defense. And the idea of those activities to be able to leverage new technologies, new processes, new equipment, and see if we can actually leverage and have a more resilient capability associated with the launch enterprise. And why is that important? Well, it's important because we need that to do our space mission. We, STP, in conjunction with our brothers on the launch enterprise side, as part of Space Systems Command, are trying to push that technology forward, have a more resilient capability, so when we need it, it's there for us to deliver the capabilities that our leadership needs in space.
So there are 4 STP-sponsored payloads on the Above the Clouds manifest. How are those payloads selected by your organization?
So all the space technologies that STP flies are going through what we call the Space Experiments Review Board. And it's a DoD-wide activity where all the different agencies and services bring their upcoming technologies and the demonstrations that they need, and then they get rack and stacked. And then once that gets approved by headquarters at Space Force, then we take those and then we execute to those. So once STP gets that list, then we work through our process, like I talked about, mission design or space acquisition or spacecraft acquisition. And then we go through that process and then we manifest, and that's how we got into this specific mission.
Excellent. So Cosmic Girl just took off. She and Launcher One are on their way to the drop point. It's going to get very exciting here soon. You know, in your view, what capability does this bring to the Space Force, the Department of Defense, and your mission partners?
Yeah, I think when it comes to mind is flexibility. We always looking for flexibility because we need to be able to act and be able to provide the technology not only that works, but also in a timely manner. And the concept that Vox has, where deploying from an aircraft, allowing that flexibility, because now you're not specifically attached to a specific ground point and the challenges that can come with that. So I think we're excited about seeing where this technology goes and the opportunity of that. This is our second launch with Vox. We did VP Alpha, and that went very well. We're looking forward to another successful mission, another opportunity to actually showcase not only the technologies that we have on board this specific capability or the specific mission, but also to showcase the ability of Vox to do their mission.
Well, thank you so much, Colonel, for coming on the program here today. That is Colonel Carlos Quinones, Director of the U.S. Department of Defense's Space Test Program, demonstrating emerging technologies in space to accelerate the development of space capabilities for the warfighter. Stay tuned for more exciting content. We're getting closer and closer to Launcher One's drop time. Stick with us. We'll be back soon.
LD's Radiohead. I can report we have good signal, good tracking on all 3 ground stations right now.
Copy, good signal, good tracking. I like it.
We're level 30,000 feet, we remain in cloud.
This copy is 30,000 feet, still in clouds.
Cosmic Curl orbit base. Cosmic Curl, go ahead. Yeah, Cosmic Curl orbit base. On the S-turn maneuver, what we're really looking for is 30 to 45 degrees of heading change in 2 different directions. It's your standard INS realignment kind of maneuver. We haven't been briefed on an S-turn maneuver. Say that again.
Yeah, this is to address the GNC Converge LCC we're currently not passing. I believe the IMU is not currently aligned, so we're looking to do that maneuver that we're describing.
Okay, that's copied. And can you repeat the maneuver? Yeah, Cosmic Curl orbit base. What we're looking for is 2 different heading changes, about 30 degrees to 45 degrees each direction. You probably won't be able to do that until you get into the Altrav airspace. Yeah, that's copied. We'll try and do that as early as we can to get an early call on it. Copy all, thanks.
Above the Clouds is our name for the STP-27VP Bravo mission conducted under the Space Test Program's Rapid Agile Launch Initiative, or RALI. The RALI project was initiated in response to congressional guidance to procure prototype commercial small launch services capable of taking research and development payloads into low Earth orbit. Above the Clouds will launch 4 STP-sponsored payloads to demonstrate flexible, responsive, non-traditional launch capability for the U.S. Department of Defense. Let's take a closer look at these payloads. The Pathfinder for Autonomous Navigation, or PAN experiment, demonstrates a low-cost, adaptable autonomous rendezvous and docking solution using 2 3U CubeSats designed with modular subsystem functionality. Technology Education Satellite 13, or TESS-13, is a 3U CubeSat experiment sponsored by the NASA Ames Research Center, exploring novel capabilities including nanosatellite class machine learning, exobraking for rapid deorbit, and advanced communications. The Global Star Evaluation and Risk Reduction Satellite, or GEARS-3, is a 3U CubeSat sponsored by the Air Force Research Laboratory to explore how a prototype patch placed on the exterior can provide details on spacecraft health via commercial satellite network connectivity. And in addition to these 4 STP-sponsored payloads, the Above the Clouds manifest also includes 3 commercial rideshare satellites. Polish new space company Sat Revolution is flying their Stork 3 and SteamSat 2 satellites. Stork 3 joins the Stork 4 and Stork 5 MARTA satellites placed in orbit by Launcher 1 on our 2021 Tubular Bells Part 1 mission as part of Sat Revolution's Earth observation capabilities with a focus on customers in the agricultural sector. SteamSat 2 is a technology demonstration for Steamjet Space System UK's innovative water-field thrusters for in-space propulsion. And finally, as a late call-up addition to the Above the Clouds manifest, from final approval to full integration in less than 24 hours, is Spire Global's Adler-1 satellite. This 3U CubeSat mission is the first privately organized satellite of Austria, tackling the challenge of micro-space debris, small particles with high velocities that can pose a serious danger to orbiting satellites. A partnership between the Austrian Space Forum, Findus Venture, and Spire, Adler-1 focuses on detecting nearby objects too small to detect from the ground. This nanosatellite detects space debris via a radar and using a piezoacoustic sensor that vibrates on impact, literally a microphone in space. Findus Venture is financing the mission, and the Austrian Space Forum is a space research organization with more than 250 volunteers from 20 countries. To these 7 payload teams, welcome aboard Launcher 1, and we wish you 100% mission success as you go above the clouds to use your technologies for the benefit of all of us back here on Earth. Now, let's hear more about the TESS-13 satellite in particular and the amazing team behind this satellite. Go ahead and roll the video.
This is Techisat number 13, and this is our second flight on Virgin orbit, which we're very happy to be part of. And this particular mission is a 3U nanosatellite, and it's full of rather interesting and innovative experiments. We're very cognizant of orbital debris, and so by having a drag device that is simple and reliable, it means that we can bring our nanosatellites down and dispose of them a lot faster, not having them as a potential debris for other satellites or human vehicles to run into.
And I'm really happy to be part of the ExoBreak team, so I was involved in the design and the building phase of the subsystem. So we are a small team, and I really want to acknowledge one of our colleagues, and I call him like the hero of Techisat. He's really quiet, really discreet. His name is Alejandro Salas, and he's our lead ops engineer.
This will be the first of a series of flights that will begin to expand on machine learning in space.
Today we got a chance to go in the clean room, do the final voltage testing. And then with the help of the Virgin Orbit team, we were able to integrate the satellite into the flight dispenser. Today was a really smooth process that my team and I hope Virgin Orbit team also enjoyed.
We command and control satellites through email, which is very unique. And we pioneered that some years ago, and it works to a great extent. We got injected into a perfect orbit, and that was a year ago, and then 9 months later, the satellite still sends lots of valuable data, so it's up there. The timing will be such that we'll have 2 satellites in orbit at the same time, thanks to Virgin Orbit.
I think TechEdsat, it's really important from the NASA standpoint, but also for the entire space community. TechEdsat group gives an opportunity to entry-level engineer to really be part of a space mission, and I think you change the entire space ecosystem because you get a chance to fly your own payload. When I was doing my master's degree at San Jose State University, I was already part of the TechEdsat team, and that's where I started working on the exobrake. So over the past years, I was able to work on 3 exobrakes. To be the first female customer, first of all, I was surprised because I was greeted here by 3 or 4 women, right, at Virgin Orbit. So I felt like home. They were all the personnel here. It's really, really nice, and they make sure we have everything to complete the integration.
We're just happy to be here again, and we look forward to 2 more flights in the next calendar year.
Thank you. Thank you to my team. Thank you to Virgin Orbit, because I also think that it's a great collaborative effort, and during this challenging year, we were able to work together, put a satellite together, and today integrate. So we are all, cheering for Virgin Orbit right now and hoping for the best.
So for those watching a live stream today, what you've most likely seen in the background is a number of graphical user interfaces, or GUIs. Now, these GUIs are composed of some of the parameters our launch team across Virgin Orbit are monitoring to make sure they keep track of the health and status of both Cosmic Girl and the rocket. Let's go ahead and take a look at one of those GUIs. These GUIs will show captive carry, stage 1 ascent, and stage 2 ascent. The current GUI that we have on the screen right now is for captive carry. To give you a little breakdown of what you're seeing on this GUI, let's first focus on the primary section of this one. Here you see animation or a comic version of the rocket itself with a couple of our tanks overlaid on top. Those tanks represent our fuel and liquid oxygen tanks. Here you can see the fill level. Obviously, since we're still in captive carry, they haven't decreased yet. Up below the rocket, you can see some of the other components that comprise our rocket, like Newton 3, stage 1, inner stage, stage 2, and the payload. Here, we're tracking some of the key parameters like temperature and pressure. Across the bottom of this GUI, you can see some other information regarding both Cosmic Girl and the rocket pertaining to bus voltage, the speed and altitude of Cosmic Girl, which you can see is flying at 420 miles per hour at an altitude of 31,000 feet, as well as our pallet and pylon, which is our separation system for the rocket. So by all means, stay tuned throughout the rest of today's mission and take a look at these GUIs as they update, as they'll provide plenty of information on the relevant section of our flight segment.
Let's go ahead and take a look at a highlight reel of Cosmic Girl and Launcher 1 taking off from the Mojave Air and Spaceport earlier today. That occurred at about 1:38 p.m. Pacific time.
And there we go. Our flying launch pad, Cosmic Girl, is up and away.
So once again, what we just saw was Cosmic Girl taking off. That actually happened at 1:38 PST, so that happened a little bit earlier today. But I'd also like to take this time to give a shout out to our flight crew. We have 2 pilots flying, Eric Bibbert and Matthew Stanley Standard, as well as 2 launch engineers. So thank you all for your hard work in making sure our rocket gets to the drop point.
LDS Radiohead, just a report that we're seeing expected losses at the point we are in the flight. All ground stations are operating as expected at this point.
Copy. Ground station is acting as expected.
Yeah.
So as Cosmic Girl carries our rocket out to the drop point, I wanted to give you a quick rundown of the flight profile you'll see our rocket complete today. To help visualize the flight path of the rocket, we have put together a little graphic for you. Once again, to start this segment of our mission, you will hear the pilots yell, "Release, release, release," when we're prepared to drop the rocket. 3 seconds after drop, we will ignite our propellant settling thrusters, followed shortly by our main engine start, which will pitch our rocket up and take us through the stage 1 flight phase. Through the next 150 seconds, our rocket will go from subsonic to hypersonic speeds as we climb up in altitude until we're about 5G in acceleration. At this point, the main engine, or Newton 3, will throttle down until all of the propellant has been expended, and we will transition to main engine cutoff, or MECO. Post-MECO, we'll go into a short coast until it is safe for stage 1 to separate away from the rest of the vehicle. Post-stage 1 separation, the rocket's second stage engine, or Newton 4, will begin its first run phase. At this point, we will have reached a huge milestone for our mission and will have made it to space. This will also mark a point where it will be safe to do fairing separation and set up our system for payload deployment. Around 500 seconds after the start of this portion of flight, we will have reached our transfer orbit and the second engine will cut off and end this first run phase. Next, we will see the vehicle enter into a maneuver we call the barbecue roll in order to ensure proper thermal balance across the vehicle. From here, we'll fly for about 30 to 45 minutes until we reach the apogee of our transfer orbit. Once we reach the desired point, we'll reorient the second stage for a quick second run phase of the Newton 4. This point will be very exciting as we have reached the final desired orbit and we will be ready to deploy the payloads for all of our eager customers. As we're flying and progressing through our mission, we'll definitely try to call out all of these milestones.
Now, Spencer, you are an aerodynamics engineer by training, and I know you love NASCAR, and you love all things fast. So, I want you to kind of geek out for a little bit here. So, tell us more about just how fast is Launcher 1 going to be flying, and, for an air launch system, what are some of the unique challenges with the early stages of that flight?
Oh, definitely. You're giving me a chance to be an aero nerd. So basically, from an aerodynamic standpoint, we break this up into 4 segments of flight, really. The first segment of flight is a separation away from Cosmic Girl, and we want to ensure that we have this correct because we want to make sure our pilots and the launch engineers flying Cosmic Girl today are safe. So we actually did work with NASA Ames and NASA Armstrong to make sure that we had safe separation down and ready to go. From here, we actually go into our, as I mentioned, 3 or 5 seconds after drop, we ignite our thrusters and we go into the subsonic flight regime. This is around Mach 0.6. Here we see some challenges like flow separation and vortices along the length of our rocket. From here, we travel from subsonic to supersonic speeds, where we then have to begin to worry about shock propagation along the length of our vehicle and making sure that we can control it through this phase. After this, we go into hypersonic speeds, where we have to take in consideration thermal effects, as well as other flow dynamic effects as well.
Now, Spencer, I heard you mention a barbecue roll. Is anyone else hungry, or did I just miss lunch?
Ooh, what's your favorite? Texas barbecue or Carolina barbecue?
I've never had Carolina barbecue, so I'm going to go with Texas for now. But anyways, getting back to it, the barbecue roll. So it sounds like a very technical aeronautical terminology there. What is it, and why do we do it?
Right, so it's simply a slow spin about the roll axis. So Launcher 1 will orient itself and slowly spin for what we call passive thermal control. So with respect to the position of the sun vector, we want to make sure that components on that second stage and our payloads don't get too hot or too cold, and so we slowly rotate, just like a good barbecue.
Man, that does make me hungry. Now I'm definitely going to have to go look on a food delivery app and see what the closest best barbecue is around here.
We'll be right back. For our mission name for today's launch, we thought it'd be a wonderful opportunity to celebrate the innovators we work with in the Virgin Group history, which, of course, all started with music at Virgin Records. Above the Clouds is a single by the artist duo Gang Starr on their hit album Moment of Truth, which was released by Virgin Records in collaboration with New Tribe Records in 1998. We named this mission Above the Clouds to pay homage to Virgin Records, the company that started the Virgin brand. We went around the factory here in Long Beach and let some of our teammates listen to the song. Let's hear what a few of them had to say about it.
So I know we're naming our rockets after albums that were released on Virgin Records, but this is exciting because he even talks about going into space on this song too, so.
Well, first of all, I haven't seen a turntable since I was a kid, so this takes me back a long way.
Back in high school, we were spinning this at house parties and really enjoying the underground atmosphere that Gang Starr provided.
Above the clouds, infinite skills create miracles. Yeah, that's stuck into my head.
Gang Starr, I'm a big fan. My favorite producer, that's DJ Premier. My favorite MC, Guru, rest in peace. My favorite Wu-Tang member, also featured on the track, Inspect the Deck.
This song is pretty dope. I like the music. The beat is pretty good. Upbeat, love it.
And I love hip hop. I grew up listening to Gang Starr, Wu-Tang. I spent most of my time just on the beach and listening to this stuff, so reminiscing, and I just don't think they make music like they used to, so.
It's awesome, you know, it's not every day that a company does something cool that involves hip hop.
Good beat, interesting lyrics, a dance beat, because it made me move, and if something makes me move, then it's good. So, definitely a thumbs up.
I think my daughter would be very proud of me that I'm in it, and I'm not like, you know, I'm not a boomer, but she says, "Hey boomer," you know, and they can stop calling me office grandpa in the office because now I'm hip.
Gang Starr are loving it.
I like it. That's a great song to name our next rocket after. We're going to be successful just like the song was.
And I want to say it's an honor to pay homage to Gang Starr in this next launch.
So let's keep playing on. Go Virgin.
During the flight to orbit, Launcher One will be transmitting a signal containing key mission information for Mission Control Center operators back in Mojave. So shown on the screen now are the locations of the ground antennas that we will use to capture this telemetry stream broadcast by the Launcher One rocket on its way up to orbit. Telemetry is on a radio frequency or RF signal containing critical information about Launcher One's subsystems, performance, and the environments that Launcher One and its payloads will be experiencing during the various phases of flight to orbit. And the ground station shown on this graphic here will receive that signal and send the data on that signal to our Mission Control Center for monitoring, processing, and to that rocket status GUI that Spencer has been showing us here on this live stream.
kill, accelerating.
Copy, accelerating.
Orbit base, LE2 confirmed, rocket is on internal power.
Base copies, rocket on internal power.
Good morning, food shell start.
For base LE1 and forward chill is initiated.
Copy, import chill initiated.
Import chill nominal. Rocket systems nominal.
Orbit base, LE2, aircraft S-band and Avis has confirmed to go.
Base copies, aircraft S-band and AFS has confirmed go.
LRC arm initiated.
Sorry, good morning. Vehicles in drop ready mode.
Copy, drop ready. Copy, pull.
Ignore warning.
Release.
Launcher 1 is drop ready, as we can see. Now, unfortunately, we're not going to have the rocket cam for the drop, but we should be able to acquire that telemetry right afterwards and begin seeing Launcher 1 on her way.
Looks like we made it above the clouds and onward to orbit.
Base copies, we're above the clouds.
Ah, it's a beauty up here.
Max Alpha flight complete.
Agent, stage 1 burn nominal.
Max Q Alpha flight complete.
Control room, we have switched back to the Long Beach dish for telemetry on S-band.
View it here.
LE2, LE1, can you repeat last?
Stage 1. We are level up, and we have a pretty good view up here.
Base copies.
So as you all might have heard on MCC, we were able to drop successfully and separate from Cosmic Girl. We have already passed a number of milestones on our way here. Currently, you can see the rocket is at 3,000 miles per hour. That's around Mach 4, 5. And so we're definitely cruising through. We already made through our supersonic regime.
Drawdown commanded.
Lieutenant 3 shutdown confirmed.
Stay step, brake wires broken.
And amazing views that we're seeing right now. The blue has gone to black, and that is the limb of the Earth in view. Launcher 1 is in space.
Fairing brake wires broken.
So what you might have just seen on the video is we just had successful fairing separation from stage 2. And our, actually, you can perfectly see the satellites right now. And that's an absolutely gorgeous view of our system in space.
Yeah, look at that. There's our integrated payload stack. Again, to our 7 customers, welcome to orbit. You know, if we have more time in the schedule before the payload deployment, but Launcher 1 is in space. What a beautiful sight.
And we're getting word now that we are having great connection with all of our ground stations.
Stage 2 PU nominal, halfway through burn.
So listening into mission control, we just heard that we're over halfway through our stage 2 burn, as you can see on our GUI on the screen. Here we're looking at some of the information about our stage 2 rocket. On the left side, you can see the gimbaling of our nozzle itself and the thrust vector there, as well as the expenditure of some of our fuels, like the fuel and liquid oxygen on board our stage 2 rocket.
1 minute to Seco.
AFSS mission rules satisfied.
30 seconds to Seco.
Newton 4 shutdown confirmed.
Okay. Coast started, barbecue roll started.
So we just heard from Mission Control that we just shut off Newton 4, so that was our SECO 1, and we've begun that maneuver that we mentioned earlier called barbecue roll.
And now launcher 1 is going to coast all the way out to orbit apogee, and there Newton 4 will burn a second time, and after that we will deploy our 7 customer payloads into that mission orbit.
Telemetry is beginning to go intermittent on S band.
Copy that.
Estimated LD on control.
Go ahead.
Looking for permission to release the airspace in the LTRAV.
Don't we need to wait until we're over land? Do we need to wait till over land?
Stand by. The answer is no. Our FA rep is shaking.
Oh, okay. Then you are good to release.
Copy that.
And we have loss of signal at Baja.
Ground on control.
Copy you on control?
Are you good to get going with this?
Yep, can do.
Sounds good. I'm going to be handing over to LC2 here.
Control room, this is GNC.
Go ahead, GNC.
SECO 1, orbital elements, apogee of 524 kilometers, perigee 194 kilometers, 45-degree inclination.
Could you repeat just one more time?
Apogee is 524 kilometers, perigee 194 kilometers, and inclination 45 degrees.
Copy all. Thank you, GNC.
Plane getting off comms for a few minutes.
Copy that plane.
Well, how awesome is this? We have successful confirmation that Launcher 1 is coasting and barbecue rolling in her transfer orbit out to apogee, but the mission isn't over yet. So be sure to follow Virgin Orbit on social media for more mission updates to follow, including confirmation of payload deployment.
We want to thank everyone who tuned in for our Above the Clouds mission today. We also want to thank our customers for flying with us. And a special shout out to our live stream production crew, brand team, and my co-hosts, Paul and Spencer.
I want to also give a special shout out to all the engineers and technicians who I can hear on mission control right now cheering in the background. They have been working diligently and they've been working odd hours to make sure both Rocket and Cosmic Girl were ready to go today so that we were successful for our mission.
We've entered into commercial service and we are delivering on our commitments to our customers. Because here at Virgin Orbit, we release,
release,
repeat.
Take care.